What's up, math scholars? We are doing 9.5 today. It's called Law of Sines. Guess what? These triangles will not be right triangles. So you can take the Pythagorean theorem idea and trash it. You can take that cosine, sine, and tangent, traditional, opposite over days and all that stuff, trash it for today. 1 second. I'm going to give you a real quick idea here, just a refresher of geometry. What the heck is AAS? Do you remember? Angle, angle, side. So today a scenario would be they're going to give you an angle measurement, they're going to give you another angle measurement, and then they're going to give you the side measurement. So this would be an angle, angle, side scenario. I call this knowing a complete set of partners because you know what this 10 is and you know what his corresponding side is, 15. So you know a complete set of partners here, and you can use the law of sines. Now let me show you what an angle, side angle scenario is. Let's say this is 15, this is 22, and this is, I don't even know, 33. This would be angle, side angle. It doesn't look like I know a complete set of partners right now, but I absolutely could get a complete set of partners if I would figure out this angle, which is called theta, because all angles add up to 180, so I can get that about 1 hot second, and then I would know that complete set of partners. Okay, so all right, so I don't think you need to write this down, but this kind of explains it. Today we will be working with non-right triangles. They will be acute and obtuse. My disclaimer is my triangles are never drawn to scale. So just because you see a triangle like this doesn't mean it won't have like a 120 degree angle. I just don't always draw my triangles to scale. Traditional usage of sine, cosine, and tangent and Pythagorean theorem will not work today with our acute and obtuse triangles. All right, this is the slide I do need to write down. Go ahead and write down that you will use the law of sines when you solve non-right triangles. You would use it when you would know a complete set of partners. And I kind of talked on the beginning slide about a complete set of partners is when you would know an angle measurement and you'd also know the side measurement across the way. This is the formula of the day. I already put it on the board. Now, sine large A over small a. Large A stands for an angle. Small a stands for a side. Same with B and B and C and C. But this looks like a huge proportion. You'll only ever use 2 at one time. So these will be proportions we will be solving with cross multiplication. So I'll pause the video to give you enough time that you need to write this down, okay? This is our next triangle. You can go ahead and sketch it on your paper. We're going to talk about what it is knowing a complete set of partners. Because you'll hear me ask that question a lot of the next week, like, do we know a complete set of partners? So knowing a complete set of partners is knowing an angle measurement and also knowing his opposite corresponding side. I'll go ahead and label him large A, and I'll label him small a. You easily could have labeled him large B and small b. You just have to use the same letter for corresponding angles and sides. Okay? So we definitely know a complete set of partners. We know large A and small a. I'll go ahead and label this 36 my large B, that's my angle measurement, and I'll label this side measurement small b. They live across from one another. Okay. Now, since we're working with A's and B's, I would definitely use the A and B part of the formula. Sine large A over small a equals sine large B over small b. Now you might be wondering, Mrs. Harp, you forgot part of the formula. Nope. You only ever use 2 fractions of the formula at a time. You would never use all 3 fractions at one time. Does that make sense? So let me put my numbers in. Sine of large A would be sine of 110. You have to sine an angle measurement. You can't sine a side measurement. So sine of 110 over 24 equals sine 36 over B. And what we have here is a proportion. Do you remember anything about solving proportions? Nick remembers. Awesome, cross multiply. So you're going to take your calculators, you're going to do 24, and you're going to multiply it by sine 36. You're going to click enter, and then you're going to loop around and divide by sine 110, and that will be what B equals. So I'll recap that in case you didn't hear me. 24 times sine 36, enter, divided by sine 110, enter. Did everybody get 15.01? Uh-oh. If you didn't, try again or check your mode. Or both. Check your mode and try again. Degree mode. All right, this one's already sketched for us. Some of the problems today you'll have to sketch yourself. That gets interesting. But we have our sketch. We have big B is 40, small c is 80. What would this 25 be? Small a, small b, or small c?
Big C. Oh.
Small c, because they're going to live across from big C. So this is big C, 80 is big C. Small c would be 25. And then big B is 40. So who would live down here? Small b. And that's what we're solving for. Solve for small b. Do we know a complete set of partners, class?
Yeah.
Yes! Who do we know? C's. We know the complete set of partners of C. So we were going to start off with who you know. So we're going to start off with sine big C over small c and set that equal to sine big B over small b. So here's going to be my setup. Sine of 80, again, you need that to be an angle, over 25 equals sine big B 40 over small b. So we went with sine C over C equals sine B over B. We're not even going to work with A because we don't need to do anything with A yet. Later today, we'll be solving the whole entire triangle and doing A. All right, let's try some cross multiply magic. Do you remember how to start this? 25 gets multiplied by sine 40. Make sure you're using sine of 40. Loop back around and divide by sine 80. Did you get 16.32? All right. The class told me they're ready for a challenge. So on this problem, we are going to sketch it ourselves. Now, I don't care if it's drawn to scale. If you want to be a scholar, you'll attempt to draw it the best you can. You see how we have a 100-degree angle? Probably better than rather just go like this, which is what I tend to do. But maybe actually attempt to make it look obtuse. Because 100 degrees would be an obtuse angle. So maybe attempt to make an obtuse triangle with a 100-degree angle. That would be at C. Hard shape. Look how scholarly that is. Now, I'm not the best artist. Brittany knows that. She actually is good at art. Where are we at? So if this is my 100, this would be my small c. I can make this an A or a B. It really won't matter. Let me just make it my A. That would make this side small a. And that leaves me with large B to be 34 and small b to be 8. Do we know a complete set of partners, class? We sure do. The B and the B. Awesome. Spencer?
Are we solving for both the C and the A in this problem?
We're going to solve for everything. When they say solve triangle ABC, we're going to solve for everything. Large A, small a, and small c. We have a lot of work on our hands here. Yes? That's what we have to do. So the question in the class, so you could hear on the video, is to solve for big A, can we do 180 minus 100 minus 34? That is the only method there is to do. So let's just do it. 180 minus 100 minus 34 is 46. So I'm going to make a list at the top of everything we personally solved for. We just solved angle large A, and we got 46 degrees. We also need to solve for little a and little c. So these are our tasks. All right, you told me we knew a complete set of partners. What ladders did we know? B. So let's start our proportion off with using sine B over B. And maybe setting it equal to sine A over A. That'll solve little a for us first. So sine of 34 over 8 equals sine of 46 over A. So you have to use a little cross multiplying to solve that one. Go ahead and cross multiply all by yourself. I won't even tell you what to type. All right, did you guys get 10.29? If not, maybe ask a neighbor how to type it in or just try it again. You want to multiply the 8 and the sine 46, divide by the sine 34. And then we can't use Pythagorean theorem to finish, unfortunately. Last week we could. We have to actually use the law of sines a second time. I would still start off with the sine b over b, because those numbers that were given numbers, they weren't rounded at all. But now let's do a sine c over c scenario. So sine 34 over 8 equals sine 100 over c. 8 times sine 100. divided by sine 34. Did you guys get 14.09? Uh-oh. I would look at what Spencer did, maybe try typing it one last time. Hey, they said they're ready to do a graduation problem. So let's see how everybody does with this. You want to sketch it yourself and solve for every piece and part that is missing. Okay. If you're watching the video, you can pause it and try it yourself. All right, let's check if you graduated. Angle A was 51, small b was 7.67, and small a is 8.58. And you can kind of check it, my work, hit pause and check my work. The homework is a worksheet front and side only, and it's actually located at the end of these notes. So if you're at home and you need a worksheet, just go pull up the notes on Polaris, okay? Thanks for watching.